Okay, today, this is the MCS review for questions 19 through 35. So we have the first question on here, number 19. What is the solution to the system below? Well, again, since we're doing with a system, there was a few different ways that we went over solving systems towards the beginning of the year. And that was substitution, elimination, or graphing. Now, on this problem, since this bottom equation is set equal to y, it'd be easiest to solve through substitution. Now remember, this is a multiple choice test. So this is one of those questions where if you completely forgot how to solve a system, you could take all your answers, plug them in for x and y, and you'd have to get a true statement for both equations. So I'm going to go through the solving process, and then I'll show plugging it in on this one as well. But on this first one, since this bottom one is set equal to y, I'm going to take this entire thing, since it's equal to this y value, and replace y in that first equation. So we have 9x minus 4 times 2x minus 1 equals 3. So we substituted in that value in the place of that one y. Now we can solve for x, because in order to solve an equation, you can only have one variable at a time. So now it's a matter of using our distributive property to distribute the 4 to both parts. So we have 9x minus 8x plus 4, because again we have to distribute the negative as well, equals 3. 9x minus 8x is just x. So we combined our like terms. Now we need to get that constant over to the other side, so we can subtract 4. And x is negative 1. Looking at our answer choices, since it's multiple choice, do I even have to solve for y at this point? Not really, because I can see that a is the only one that has that as a option. Now, if I wanted to double check to see what y is, I could take this x value, plug it into either equation, solve for y. The bottom equation is set equal to y, so that would be the easier one to solve for. So we could take that bottom equation. Instead of that x value, though, we should plug in a negative 1. So 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So our answer is an x value of negative 1, a y value of negative 3. If you were doing the guessing and checking method here, because you couldn't remember how to set up the system, you have had to plug this into both equations and see if you got a true statement. So if we had, let's say we had started with c, all right, and plugged that one in first. Well, if we had plugged in the values for c into, I think the bottom equation is the easiest one to do. So I'd probably use that bottom equation first for all these and see if it works. So you'd have 3 equals 2 times 1 minus 1. Well, 2 times 1 is 2. Minus 1 is 1. That's not a true statement, so that doesn't work. So like we could have eliminated c. And you could have done that until you found a point that worked for both of them. So then when we plug this one in, we would have had negative 3 over there. And we already saw from doing our work here that we do get negative 3 on that other side by plugging in negative 1. So you've had a true statement. Again, it would also have to work in the first equation in order for it to be a solution to the system. So you do have to check both equations if you're going to use the guess and check method. All right, on number 20. What is the solution to the system below? So on here, now these are set up in the same format so that the x's are over top of each other, the y's are over top of each other, and the constants are over top of each other. This is set up in a format that would be easy to use elimination method. Now, in order to use elimination, we have to have exact opposites for one of the two variables. Because in elimination, we're going to combine them by adding the two equations together, and we want one of the two variables to cancel out when we do that. So, in order to get opposites, we have to multiply at least one of the equations by a value. We might have to multiply two of them. So, here I have a 3 for my x. Well, I can't just make 3 into a 4 very easily. And then I have -2 for y. I can't make that 2 into a 3 very easily either. So we're going to have to multiply both equations. Now, I'm going to use the two smaller numbers. So I have the y values of -2 and +3. Well, 2 and 3 both go into 6. So that's what I want to shoot for. I want to make both of those values a 6. One a positive, one a negative. So I can multiply the top equation by 3 in order to get a -6. I could multiply the bottom equation by 2 to get a +6. So I'm going to rewrite this with these values being distributed to every single term. That would be 9x minus 6y equals 27. And the bottom equation would be 8x plus 6y equals 58. So now, combine those two equations together. So if we add those two equations, 9x and 8x gives us 17x. The y's cancel out, give you 0y, which again you don't even have to write because they canceled out. And then 27 and 58, that'll give us 85. So now we have 17x equals 85. Divide by 17. And when we divide 85 by 17, we get 5. So the first part of our answer, the x value is 5. Now, again, looking at those answer choices, there's only one answer that has 5 as that x value, and that's D. Now, if we had more than one option, we would want to plug it back in and solve. And again, we can plug it back into either the originals or either ones that we had multiplied by a number in order to solve for y. So again, I'm going to work through it because it's not guaranteed that this is going to find you the answer every time. You will have to plug it back in sometimes. So I'm going to use the top equation since they're the smallest numbers. We have 3. Again, we're plugging in 5 for x. Minus 2y equals 9. 3 times 5 is 15. Subtract off 15 from both sides. And that would leave us with -6. Divide both sides by -2, and you get a +3, which is what we had for our y value on D. Now, on both these problems, I had solved for x first. You don't necessarily have to solve for x first. You could solve for y first. So like on that last one, if I wanted to, I could change the first two terms to be opposites by getting them both to be a +12 and a -12. Solved for y, and then went from there. On 21, what is the value of y in the system below? Now, there's a lot of stuff going on here, and this time they don't give us an x and a y. So, unlike the other problems where we could just take our values and plug in, we don't know what our x is. So we do have to solve on this one. So first thing I would do is try to get this into a format that is a little bit easier to solve. So maybe get both of them into the same format, or get one of them set equal to a variable. That bottom equation looks a little bit complicated, so maybe go ahead and get rid of the 2 by distributing it to both of those. So we would have 6y minus 2 equals x plus 1. Now, we have a few of these that are both constants, so we can go ahead and combine those. So on here, I could go ahead and bring that 2 over to the other side. Or actually, let's go ahead and bring the 1 over to this side. So we have 6y minus 3 equals x. The reason why I decided to bring this one over here is if I look at the first equation, I had x by itself, and then I had a y and a constant. So now they're kind of in the same setup. Yes, they're flipped, but again, we can go ahead and flip this so that they are in that same setup. Or I could go ahead and just flip that first one. So taking this equation, I'm going to rewrite it down here. We have 7y, we have a positive 4, and we have a 2x. Currently, we don't have opposites. But we could make these opposites by multiplying that top equation by a negative 2. So we could get these x's to cancel out. So I'm going to multiply that whole thing by negative 2. So that'll give me 12, negative 12 y plus 6 equals negative 2x. So now, these two I can use to solve. Add these together, and the x's cancel out, so I just have 0 over there. Add these together, I get 10. Add these together, I get negative 5y. Bring the 10 across by subtracting it. So now we have negative 5y equals negative 10. And last step, divide off negative 5, and y is 2. We don't have to solve for x on this one, because that's not part of what the question was asking for. And again, that was a harder question. I doubt many of the questions on the test will be that level. That was very challenging. Now again, there's other ways to solve it. We could have set this top equation equal to x and plugged it in. Again, there's more than one way to do that. How many solutions for x and y are there to the system of equations below? So, on this one, again, we need to start by going through the process of solving, just like we would for the other ones. So, get this in the same setup. I could go ahead and bring this y over to the other side. So we have 9x minus 6y, because again, subtracting 6 to bring it over to the other side, equals positive 12. And I have 12x minus 8y equals 18. Now, on all the other problems that I used elimination, I went ahead and multiplied my values by something to find a common value that would be opposites. On this one, notice all of these numbers actually have some common factors. So you could also use division to find a way to make them equal. So like on this top one, all three of those numbers are divisible by 3. So if I went ahead and divide all those by 3, I could make this a little bit easier. So I'd have, again, same idea. Divide by 3 or multiply by a third. Get 3x minus 2y is equal to 4. On the bottom one, now I want opposites, so I'm going to go ahead and divide this bottom one, which when I say divide, again, you can also multiply by a fraction, but divide this by 4. All right, and I'm going to do a negative 4 so that I have a negative 3. So again, if I divide by negative 4, or same thing as saying is multiplying by a fourth, this would be negative 3x positive 2y, and this last part, 4 doesn't go into 18 evenly, but it will give us a pretty nice decimal of 0.5, so it goes into 16 4 times, so this would be 4.5. Again, it's still negative. Add these two equations together, and notice what happens. Both of these cancel off, so I have nothing left on this side but 0. On this side, I'm left with negative 0.5. I don't have any variables. All I have is a statement that is incorrect. So since we have a false statement, that means that there is no solution. So if I look at my answer choices, there are 0 solutions that would work for that equation. Again, you could use one of the other methods to solve. Again, you could set 1 equal to x, plug it in. That works same as any of the others. All right. Number 23. Which of the following systems has infinitely many solutions? Well, infinitely many would have to mean that the equations are pretty much exactly the same. Now, because infinitely many means that they're going to be 2 lines on top of each other. I can go ahead and cross off D right away because one of these is a horizontal line, one of them is a vertical line. So that's not going to be the same line. On this one, well, again, they switched my x and y around. They equal to different things over here. Not going to be C. So I'm down to 2 options that could work. Now, in order for this to work, they have to be the same exact equation. So I would look to see if we can simplify these down to the same terms. So like on letter A, we have all those are divisible by 3. So I'm going to go ahead and divide these by 3, see what we get. 3x minus 4y equals 12. I'm going to do the same thing here, but now a common factor that they all have is 4. So divide all of them by 4. I get 4x minus 4y equals 8. Well, are they exactly the same? No. Oops, and I made one mistake. This one, sorry. Divide by 4, and we should have had 3 there. So are they exactly the same? No. These two are the same, but this last one's not. So that's not going to give me infinite. This would actually be another one where we would end up with no solution. So let's go down to B. All right. Here, that top set, I could divide all those by 5. So I'd have 3x plus 2y equals 8. This one on the bottom, I could divide all those by 4. And again, what's going on? We have 12 divided by 4 is 3x. 8 divided by 4 is 2y. 32 divided by 4 is 8. These two are exactly the same. So B would be our solution. Again, in order to have infinitely many solutions, that means both equations are exactly the same. Could you go through and actually solve for each one of those? Yes. But knowing that in order to get infinite solutions, the equations have to be the same, by just dividing out the common factors, you're able to find which one it is a little bit faster. On 24, what is the slope of a line that is parallel to the line graphed below? So, parallel, it's going to have the same slope. So, if we find the slope on this one, so pick 2 points that we can clearly see it goes through. We go up 2 over 1. So again, our slope is up 2 over 1, or just positive 2. We want parallel, so again, it stays the same. So that'd be D. What is the slope of a line parallel with the equation here? Well, in this format, this isn't going to tell us the slope just by looking at it. We could change this to slope-intercept form, which is y equals mx plus b. And then the m would represent the slope. So if we solve this for y, we could find our slope. So let's get the 4 over to the other side. Hey, how's it going?
What's going on here? What's today? I know today's Wednesday.
He's not here today.
What about this one?
Nope, she's not here today either. Sorry.
Thank you. Okay.
If they show up, do you want me to send them down?
That would be fabulous.
Okay.
Thank you.
So, subtract 4 from both sides. We have 6x minus 4 equals 2y. Divide off the 2. Six divided by 2 is 3. 4 divided by 2 is 2. Now, this is kind of flipped, so if you want to flip it, you can. Our slope is in the end position there, which is next to the x. So 3 is our slope. We want parallel, so we want it to be the same. So D is our answer. Now, number 26. This one asks for, instead of a parallel line, it asks for a perpendicular line. So now slopes are opposite reciprocal. So first thing we have to do is find our current slope. So pick 2 points we can clearly tell it goes through. Ooh, actually, I don't know if it goes through both those points. Hold on, let me look again. Let's use these two. Alright. So, goes up 3 over 5. So, the current slope is positive 3 over positive 5. So the opposite reciprocal would then be negative 5 over 3. So negative 5 over 3 was A. All right, on 27. What is the inequality of the graph below? So, first thing I notice, I see a dotted line. So since there's a dotted line, which 2 could you eliminate right away? The 2 that have the equal signs, the and equal to. So those 2 are not the correct symbols, because those would be solid lines. Now, we are shaded below. Since this is set equal to y, in order to shade below, the y value would have to be less than the rest of the equation. So the correct equation here has to be this one. C. Because, again, we have a dotted line, so it cannot include the and equal to, and it's shaded below, so if y is less than, we're shading below the line. If y is greater than, we'd be shading above the line. If you had the and equal to in there, we would have had a solid line. Alright, let's go to the back. Alright, we got a system. Now, first thing I notice is both lines are solid. So automatically, we can get rid of C and D, because those 2 do not have and equal to's in their symbols. Therefore, it can't be a solid line. So it has to be between these 2. So we're down to a 50-50 chance of getting this right. Now, pick one of the 2 equations. Well, if I look at these, there's actually no difference between the equations themselves. The only difference is in the inequality symbols. So 2 of these say less than or equal to, where the other 2 say greater than or equal to. Well, in both cases, this shading is below the lines. So that means that it would have to be y is less than the rest of the equation, which is what they represent with A. So since y is less than, again, it's being shaded below. All right, on 29. In the figure below, the cost of a rental car is shown in terms of the miles driven. So, what is the meaning of the y-intercept? So the y-intercept is where it started there. All right. And again, this is miles driven. And over here is the total cost in dollars. So, if we're at 0 miles driven, but the cost is up here at like 33, what do you think that 33 represents? So we haven't driven it at all yet. We're at 0 miles. So does it have anything to do with driving yet? No. So it's definitely not going to be B. All right, because that's still talking about miles driven. That can't be it. Is that the maximum cost of renting a car? Well, this graph keeps going up, so that can't be it. The average cost to rent a car? Well, the average would be somewhere in the middle, so that's not it. The lowest cost to rent a car? Well, that's the lowest point on the graph, and it's our starting point. That would be the value you have to pay before you drove any miles. So, D is the correct answer. Again, that's before you even drive it at all. That would be the cost to rent it, even if you didn't drive it. All right. On number 30. Using the graph in the previous problem, what is the meaning of the slope of the graph? Now, the slope, again, it's increasing in cost compared to the number of miles driven. So this would be the cost per miles driven. Again, slope is always a rate of change, so it's comparing two values. So this time, it is B, the cost per mile driven. Again, if you're unsure how I did that, you can look at this. Remember, slope is change in y over change in x. What's the y value represent? Y represents cost. X represents miles. So cost per miles. All right. On 31. The balance in Revew's saving account each week can be calculated using the equation below. What is the mean of the number 300 in the equation? So, again, anytime it's written in that slope-intercept form where we have a number multiplied by a variable and a constant, that constant is our starting place. So this is what would be in the account when it's first open. So if we look at this, amount of money deposited when the account was first open, that looks good. It's going to be A. If we look at some of the other options, amount of money in the account when it's closed, no. The amount that was deposited each week, no, that would be the $25. The amount that's withdrawn each week, well, this equation doesn't show us anything about being withdrawn, so it is just A. Yeah, the amount of money when the account was open. On 32, Vernon set up a snow cone stand. The equation used to determine profit is P equals 3C minus 25. What is the meaning of the number 3? Well, if you have 3 next to a variable, again, that's our rate of change somehow. So, is it the total amount of profit shown? No. Is it the number of snow cones sold? No, that would be C, represents that number. The cost of supplies, that's probably the negative 25 to start off. So now, the amount he charged for each snow cone. Again, it's a rate of change, so we should be comparing two numbers. The amount charged for each snow cone. D is the correct answer. Yeah, 33. There are 30 students in a class. The ratio of students who play sports to those who do not play sports is 3 to 2. How many students play sports? So, The ratio of students who play sports to those who do not play sports. This is a tricky question because the ratio that they have here, a lot of people would say, hey, we're going to set this up 3/2, and over here we're going to have to put 30 over in one of these two spots. But that wouldn't be accurate because that 30 is the total. The 3 and the 2, neither one of those represents the total. So actually, we need to change this ratio. We don't want the ratio of students who play sports to those who don't play sports. We want the ratio of how many play sports compared to the total. So this is telling us 2 out of 3, so there's a total of 5 when we're using these numbers. So 3 out of 5 students play sports. So X out of 30 would play sports. So we did the number that play sports out of the total. Number that play sports out of the total. Now we can cross multiply and solve. So 5 times X, 3 times 30, so that's 90. Divide by 5, and that would be 18. So there are 18 students who play sports. So again, kind of tricky because you had to change the ratio that you're using in order to help solve that problem. On number 34, 3 owners of a company have shares in the ratio of 3 to 2 to 1. The company profit for this year was $600,000. How much money does the owner with the greatest stake get from the profit? Well, here we have 3 to 2 to 1. There's a total of 6 shares there, right? So there are 6 shares total if we add those up. So if I take this and figure out the amount per share, so 600,000 divided by 6, that's 100,000. So this is the amount per share. So how much money does the owner with the greatest stake get from the profit? Well, 3 times the per share amount, so 3 times 100,000 would be 300,000. So C is our correct answer. And finally, 35. For a floor plan, 1 inch represents 5 feet. Right. The dimensions of the living room are 4 inches by 3 inches on the floor plan. What is the area of the actual living room in square feet? So again, each inch represents 5 feet. So if we take the inches and multiply by 5, we would be able to determine how long each side actually is. So I had a 3 by 4. We're talking about in terms of inches. On the opposite side, I'm going to go ahead and write this in terms of feet. So 3 times 5 would give us 15 feet. 4 times 5 gives us 20 feet. So 15 times 20, because we're doing area, 15 times 20, base times height, that'd be 300 square feet. So that answer is C. So those are all the answers for questions 19 through 35.
Dr. Drew.